child was once thought to be born a blank slate, filled in over time by experience. For many years, the prevailing notion was that environment, largely created by parents and teachers, shaped a child's personality and behavior. But there's been a shift in thinking among many psychologists about what makes us tick. Ongoing studies suggest that biology and even genes play a big role in determining what kind of people we are. Recent research has stirred up the nature-nurture controversy once again.
Here in the nursery at St. Peter's Hospital in New Brunswick, New Jersey, these 2-day-old infants seem to have a lot in common. But psychologist Michael Lewis is interested in what makes each different from the others. Even at this early age, he detects distinctive budding personalities.
The study of personality mirrors what I would call worldviews. The first worldview essentially says that any of the personality variables that we think of, these are essentially acquired through the child's interaction with the environment. The other worldview suggests that children are born with dispositions, with characteristics which are likely to lead to certain kinds of personality.
Dr. Lewis is studying differences among newborns by observing how their reactions to stress vary. On the second day of life, all infants are tested for PKU, a condition that can lead to mental retardation. The test involves lancing the heel to remove blood. Since at this point, babies have had little interaction with their environment, Dr. Lewis believes their reactions reveal innate dispositions.
What we've been doing is examining really two aspects of the children's response. The first is the initial response. How much stress do you need before you get upset? The second is, once you're upset, how quickly can you comfort yourself, or what we call dampen the response? It turns out that children differ on both of these responses. Right. Yeah. The little boy, if you notice, once he is cut slightly with a knife, starts to cry, and he cries immediately in a full-blown cry. He continues to cry throughout the procedure, unable to dampen his own upset.
In contrast, this little girl hardly cried at all during the procedure.
These two children really give us a difference in how they're responding to stress. And that difference that we see in their second or third day of life, amazingly, is likely to be seen at 2 or 3 months when they're taken to get their DPT inoculation shot. So these differences are likely to be maintained.
In a related study, Dr. Lewis observed how 4-month-old babies in Japan and the U.S. reacted to inoculations.
The results are absolutely amazing. We find that the Japanese children in general do not manifest as much external response to stress as do American children. They don't cry as much, their facial expressions don't indicate pain as much as American children. In fact, we find 30 or 40% of the Japanese children don't cry, whereas 100% of the American children cry. Exactly where these differences in groups come from is not clear. When you look at differences in children at 3 or 4 months, the question remains as to whether or not these differences are innate, inborn, or whether they're socialized. The difference in the treatment of a Japanese and American child is so immense that one cannot exclude the socialization factor. For example, Japanese children are always in close proximity to mom. The idea of the Japanese baby having its own room or having its own bed is not viewed as appropriate. And so the baby is always with mom. If the child is with mom, then when it's distressed, it just simply has to make a little sound, and mom knows what to do. The American child, on the other hand, having its own bed and its own room, really has to let mom know it's distressed and bellow out an upset. So that difference alone could account for why Japanese and American babies differ in their response to stress. However, we also know that these differences at 3 months that we see in American babes can be related to differences at 2 or 3 days of life.
Another focus of study by Dr. Lewis and his team is how infants express anger.
Anger has been studied mostly in older children, and the reason has been that children, younger children, don't seem to express anger. We believe that anger will be expressed if, in fact, we can find a situation in which we can frustrate a very young child.
For this experiment, 2-month-olds learn in a matter of minutes that if they pull on the string attached to their wrist, a slide of a baby appears. At the same time, they hear the theme to Sesame Street. Then the machinery stops working in order to frustrate the infants.
Now, the majority of the children in response to this frustration show anger. Some children, interestingly enough, show no response to this frustration. Finally, a small percentage of children show sadness rather than anger when the machine stops paying off. These children who are angry may, in fact, come from environments that are more frustrating. On the other hand, it may be the case that anger is dispositional.
Another group of psychologists is trying to understand what makes some children more shy than others. In a lab at the University of Maryland, children are videotaped behind a one-way mirror while introduced to a novel situation. When a clown appears, this shy young boy clings to his mother. In contrast, this outgoing young girl eagerly engages the clown in play. Psychologist Nathan Fox has found that brain activity, as measured by EEG, differs between shy and outgoing children.
What we found is that the shy or inhibited children seem to show greater activity in the right part of the brain than in the left part, and particularly in the right front part of the brain as opposed to the left part. Whereas the children who are more extroverted, they show more left hemisphere activity.
Dr. Fox has studied these youngsters since they were a few days old. He has found that each child's EEG readings have been consistent over the 3 years he has followed them.
I would argue strongly that that indicates that biology is playing a strong role in early personality development.
Can we get these on?
Another study at the National Institutes of Health focuses on other physiological and behavioral signs that an infant will grow up to become a shy child.
In the laboratory, we collect heart rate and cortisol data. Cortisol is a substance that the body produces under stress, and we can do that by getting a sample of the child's saliva. We get a measure then of the levels of cortisol in the body. Heart rate is also a variable that we know to be related to a stress response, and we believe in both cases heart rate and cortisol will distinguish the groups who are very wary and vigilant from the kids who are more outgoing and comfortable. We also put the children through a standardized battery where we present them with a series of stimuli. What we're interested in, of course, is the individual differences in how children respond.
The mother of this 1-year-old reported that during the first 4 months of life, she had symptoms of irritability. Dr. Rosenberg's hypothesis is that children with colic, difficulty sleeping, or chronic constipation in early infancy are more likely to display wariness in response to novel stimuli because they are easily aroused. She is finding that many of these children have elevated cortisol levels and high, stable heart rates. By comparison, children like this one, who did not manifest symptoms of irritability in early infancy, tend to have lower cortisol levels and variable heart rates. They express pleasure and interest rather than wariness when presented with novel stimuli. Dr. Rosenberg predicts that a baby like this may be more likely to become an outgoing child.
1, 2.
In addition to trying to establish that babies are predisposed to be wary or outgoing, Dr. Rosenberg and her assistants are investigating how parenting styles can modify a child's predisposition. This involves observing mother-child interactions at home.
We have the expectation that a mother who is very sensitive and responsive and lets the child set the level and tone of interaction, we think that that'll promote a more moderate, less wary or inhibited profile in the child at later ages.
Also, at the National Institutes of Health, parallel studies are underway with rhesus monkeys. Despite obvious differences from humans, these animals have 96% of the same genes as humans. A big advantage of studying monkeys is that they go from birth to maturity in 4 years as opposed to 20. Also, it's possible to breed monkeys so that they are likely to have particular personality traits.
Monkeys have as different and varied personalities as you will find in most human groups. Some individuals are exceedingly outgoing and adventurous. Others are especially friendly socially. Some are relatively shy, and some are quite timid.
I got a treat for you.
We're interested in identifying personality differences among our subjects as early as possible to understand what the basis for these differences are and to see if and when they can be modified during development. We found in our monkeys that the patterns of early development, particularly up to the age at which human children develop language, are virtually identical in sequence and in quality, in terms of qualitative changes, as what you see at the human level.
Good girl.
The tests that we use in newborn infants, and in Marcelina's case, a 6-month-old infant, are really taken from the human literature. These are tests of basic reflexes and motor capabilities, of temperament and response styles, and physiological patterns.
Good girl.
Marcelina is a very outgoing and confident monkey. She scores very highly on all of these neonatal tests, and we now know that she's now a little bit older than when that film was taken, that she's one of the more social animals in her group, and actually is one of the higher animals in the dominance hierarchy in her group of peers.
In another test situation, monkeys are let out of their group cages into a mesh tunnel that leads to an enclosed field.
What happens is monkeys who are unusually bold and adventuresome readily run through the tunnel and go out into the new environment or enclosure where we can provide various types of stimuli that they might find interesting. But not all monkeys go charging into this new setting. Others are much more cautious and careful, and in fact some almost never come out at all. Just as our monkeys differ in how they respond to novelty or challenge in their environment behaviorally, we also notice physiological differences as well. A variety of different systems inside the body clearly differentiate what we call high reactive or timid animals from those that are more relaxed or laid back.
Differences are reflected in heart rate and levels of cortisol, the peptide ACTH, and the neurotransmitter norepinephrine.
The pattern of individual differences we see in personality and in underlying physiology, these differences that are so pronounced when the monkeys are faced with novelty or challenge, we believe is basically of genetic origin. That is, we have found by comparing close relatives of one another that this tendency tends to run in families. It is a predisposition that these monkeys have that puts them at risk for developing some problems of behavior and physiology later in life. However, it's just a predisposition. It's not an absolute prediction, because it turns out that environmental effects, especially those things happening very early in life, can modify this genetically based predisposition. And we have found, for example, that it's possible to take monkeys who are genetically at high risk to develop this anxious or shy or withdrawn personality, and by pairing them with foster mothers who are unusually nurturant or supportive, we find that in this kind of early rearing environment, the at-risk animals actually thrive. They develop more rapidly and show greater exploratory tendencies than their genetically less reactive counterparts. And in fact, when their social support system that's developed by these nurturant foster mothers is maintained, these monkeys actually come to the top of the dominance hierarchy and prosper. So here you have a perfect example of an interaction between genetics and early environment.
Other personality research is focusing on how environment and biology make some people cautious and others willing to do things like this. For Rocky Aoki, thrill-seeking takes many forms. He holds the world's record for the longest balloon flight in history. He's involved in endurance auto racing, like the One Lap Around America contest. Aoki used to be one of the world's top powerboat racers, but he stopped racing boats after several accidents, one of which nearly killed him.
I always say, if you're afraid of dying, probably you're afraid of living also. So, you know, if I die, I die, but I know I'm gonna survive for a long time. I have to believe that.
Risk-taking for Aoki is mental as well as physical. With $10,000 in startup money he earned selling ice cream from a truck in Harlem, he started the Benihana chain of restaurants. Before long, he was a millionaire.